Okay, so today we're going to do problem number 8 in Project Euler, largest product in a series. So this one is kind of unique to the rest of them so far. We have this long 1,000 digit series of numbers, and it's asking us to find the 13 adjacent digits in the 1,000 digit number that have the greatest product. So somewhere in here there are 13 digits that when you multiply them all together will have the largest number, and we got to find that number. So we got to do two things. One, we're going to open a new VI. We're going to copy this prompt in. But I'm also going to create a string, and I'm going to copy the numbers themselves in. I think that's how it's intended to go. So yeah, it looks like they are. In that kind of grid order. The first thing we want to do is get these numbers organized a little bit more neatly. So in order to do this, I'm going to look at this slashcode display. And you can see here, oh, this made it very annoying. Okay, so you can see that one thing that did happen is it added these slashes. So what I've done is I have copied in this string of numbers into a LabVIEW string. And I'll show you there's a few different ways you can look at this. You can show a normal display, which will show you like what a text document would show you. So carriage returns, line feeds, tabs, things like that will not have any, they'll just show up as white space. This slash codes display, which is what I have here, will show you not only the ASCII text, but it'll also put these slash codes in. So it will show you what actually is made up of this string is actually made up of a bunch of numbers with new line characters inserted, and that's how you get these. You can see the lines themselves are built into the string. They don't wrap with the size of the constant. They are defined by something else, and it is these /n codes. You can also look at these as password display, which just shows a bunch of stars. That's helpful if you're making like UIs and things like that. And also you can look at a hex display, which actually shows you the binary ASCII representation of each of these digits. So we're going to look at this. I'm going to delete this, and we're going to actually look at this in this /n format. So I think the first thing I'm going to try here is I want to remove these /n's, because what I want to be left over with is a long string of numbers without any other white space characters. And so what I'm going to search for, I think this will actually work. If I just hit enter and then change this to slash codes display, yep. So I'm going to search for /n. And if I find that, I'm going to replace it with an empty string constant. I think this will work. Let's see what happens. Create indicator. I'm going to do the same thing over here. Change this to /codes display and see what we find. No, they're still in there. Okay, that doesn't work. Oh, we need to create this object. That's my problem. I think I need to make it too long. Let's try this again. Nope. Maybe I need to change this to be a end of line constant. Let's see if that works. Nope, still in there. Let's see. Let's try a line feed constant. Try that again. There we go. Okay, so it wasn't a end of line constant. What the /n is actually a line feed constant. So by taking the original string, which I just copied from the website, and really this is that copy operation, you can see actually right here, this blank spot I think is where the new line is. It doesn't really like show up. It's kind of a weird representation, but that's that. The fact that these new line constants are in here is more a result of my copy operation. Obviously, they're not intended to be here. It's not like they gave you a binary string to work with. It just gave you these copied numbers. But when I copied them over into LabVIEW, they do include those new lines. So, those line feeds. And so what we need is something without those. I think this is what we want. Just to make sure, I'm actually going to look and get the string length of this, it should be 1000, because the problem told us that there were 1,000. Yep, there were 1,000 numbers in here. If we look back over here, the 1,000 digit number, and you can see we have 1,000 digits within this number. Interestingly enough, let's look at what this one looks like. This should give us like 1,020 or something. Yep, 1,019, because it is including these line feed characters. So it's good that we did the work to get those out of there. Okay, now that I have got my string cleaned up, I'm going to delete this. I'm going to delete this too. I don't need that. What we want to do is cycle through one character at a time, each of these numbers, until we get to the end of the string. So in order to do that, I am going to use actually this VI. It is called string subset. I'm going to put this in a while loop. Actually, I'm going to put it in a for loop. Nope, I'm going to put it in a while loop. And I am going to use the offset and this control right here to determine how many characters I want to pull off of this string. I'm going to use that same string length function to make sure that I'm actually getting 13 elements out of here. And I'm going to create a true here to stop it the first time. And this should be 13 elements long. And if I look at this string, it should be the first 13 digits in here. So 7316, and it ends in 133. So that is the first 13. If I run this twice, let's see here. Let's do this. Put on this here, and we'll make this false, and we can kind of watch it go through. And actually, I'm going to put a breakpoint right here, so I can see it each time. What we should see, is each of these numbers progress by 1. And so we're going to go again, and now we have 316, and it ends in 330. Okay, so we can see that. And now we should have something starting with 167 and should end in 306. Okay, and so on and on and on until we get to the end of the string. Now, what this currently doesn't do is stop ever. And so we want the condition for this to be that it stops if the length is ever less than 13. Because if the length is less than 13, create a constant, then that means that we have got to the end of the array, or end of the string here, and we don't have 13 numbers, or we don't have 13 characters left for this to pull off. So the very last string should be this one right here. So let's go ahead and run this, and we'll make sure we're getting that string. And we can see very clearly 420-752-963-450. And there we are. What actually happened is we got the last 12 numbers, and so we know that we need to not consider the very last version of this. We need to not consider the very last iteration of this when there are only 12 and not 13. So we'll use this true here to eliminate that very last case. Okay, so now the next thing we need to do is we need to take this string and we need to break it up. So I think the way that we actually want to do this is take this string in here, and we're going to just cycle through each number one at a time by using the string subset. And we're going to do this instead of 13 like we did last time, we're just going to do 1. And so what we should end up with here is an array. Let's see here. What did I do wrong? We need to do this 13 times. What we should end up with here is an array of single numbers that are the last. Again, it's these numbers here, but now in array form. Okay, and now what we're actually able to do is go string, and we're going to do number conversion, and we're going to go decimal string to number, and we're going to plug this in here. And then what we should actually have is an array of a single array of now not the string data format, but an actual number data format that is this same number of elements here. We get a 0. Okay, yeah, so what we actually have now here is an element that is 13, or an array that is 13 elements long of just numbers. And you can see the last one is 0 because we told it to go 13 times, but there's not 13 characters here, and so by default it puts in a 0. Okay, so what we actually have now is an array of numbers that we can just simply multiply together that are all of these elements, and not in string form, but now in number form. So we're just going to use this multiply array elements function, and I am going to look at the product of these. Now, something that is interesting is that any one of these that has a 0 in it is going to be 0. And so you can see there are zeros periodically throughout here. And what this is actually going to do is kind of make like, I don't know, like a dead band that is 13 elements wide on both sides of this 0. Because any of these numbers that are multiplied by 0 are going to result in a 0 product. So I've got 13, so let's run through this, and what we're actually going to get here, just to see how this works, is we're going to get an array. I want to index this, tunnel mode indexing. We're going to get an array of these multiplications that are each subsequent 13 numbers multiplied together. And you can see there's that dead band in here because there's this 0 here. And so 13 elements wide, anything that's multiplied by 0 is going to end up being 0. So then all we need to do is find the max of this array. Oh, it's called array min and max and min. And whoops. And this should just give us the largest array here. Indicator. Max product. Max product. And if we run this, we get the number. Let's see, what is this? 100,000 million. Is that right? 100,000. 2,091,059,712. So let's go over here and look at our random solution guide. And we can see here, problem number 8. Okay, we have some sort of bug here. Let's see, this says problem number 8 is, much larger number. 23 billion, and what I have is 2 billion. So let's see what we maybe have going on here. Okay, I just all of a sudden realized what my problem was, and it is stupid. So we're using this I32 type. Sorry, Control H. Let's get this over here. We're using this I32 type to find my product here, and that number is too small. So what do I mean by that? An I32 is 32 bits long with a positive and negative integer, or sorry, with a positive and negative bit, and so it can only hold a number that is smaller than this number right here, or negative this number here, larger than this. So I know that the answer is 25 billion, which is more than 2.1 billion. So what I need to do is convert this first to a larger data type, to I64, that's what I want, to a larger data type that has more bits and can hold larger numbers. And that means I'm going to have to change this to I64 and this to an I64. Then if we run this again, let's pull this over here and see if I find my right answer. Okay, much better. Now my actual answer is problem number 8, 25,514,624,023, 514, 624. So let's get rid of all this. I was doing a bunch of debugging. I don't need any of this anymore. This, I don't need this. Get rid of that, and I can get rid of that. Control B, Control U, and we'll run this, and here we see we get the correct answer. Now this is a good lesson. And so far, right now, we haven't run into this problem, but I have said it multiple times. Assuming the number is larger than or smaller than 2.14 billion, then we'll find it. This is an obvious case where we run into the computational realities of storing large numbers in binary format. So what we actually had, let's delete this here. What we actually were getting was the largest product. Oops. What we were actually getting was the largest product that was within this I32 range. So you can see we got something that's just below 2.14 billion. So this happens to be the largest number from all of these products that fit in that size. That's why we were seeing it. Okay, let's undo all this. Oops, Control Z, and get back to our application that actually works. We'll save this, and that is problem 8 in the largest product in a series, Project Euler. Okay, and that is problem number 8. See you next time.